this one I'm going to do an integral that's a little bit more complicated, and it also involves using L'Hopital, so it makes it kind of extra cool in a way. Okay, so first thing I want to do is I know that this is going to be equal to the limit, right, as b goes to infinity, the integral from 1 to b, 1 minus x e to the negative x dx. First thing I'm going to do, I'm just going to deal with this integral and as an indefinite integral, so I don't worry about the limits right now. I got 1 minus x e to the negative x dx. The only way to do this one is by parts, which is, you know, it's kind of nasty, but it's okay. So I'll make u 1 minus x. I'll make dv e to the negative x, right? So du is negative dx, and v is negative e to the negative x. So that this thing here is equal to, remember, it's u times v minus the integral of v du. So u times v, we've got 1 minus x, negative e to the negative x, minus the integral of v du. And so that's negative e to the x times negative dx. The negatives cancel, right? So you just end up with e to the negative x dx. And box this out so it doesn't confuse us too much. I can go, I'm going to take this negative 1. I'm going to make this x minus 1 times positive e to the negative x. I think that's easier. And minus the antiderivative of e to the negative x is negative e to the negative x. So negatives will cancel, and I get positive e to the negative x plus c. Because it's indefinite right now. Well, it'll be definite in a second, but we're just evaluating as indefinite right now. Now I'll do one thing, because this is going to be super cool. So this may look kind of nasty, but actually it's not that bad to deal with on its own. But watch what happens when I do this magic. Okay, I'm going to distribute the e to the negative x e to the negative x minus e to the negative x. Right, so I just distributed e to the negative x here, and now I've still got my e to the negative x over here. And oh yeah, these guys cancel out, and I'm left with x e to the negative x plus c. Why is that cool? Because check this out. All right, go back to our original thing where we had a limit as b goes to infinity. The integral from 1 to b of, what was it? Right, x, or no, it was 1 minus x, right? 1 minus x e to the negative x dx. I got that right? I feel like I'm doing something wrong here. Oh, that looks good. And I'm saying that that's going to be the limit as b goes to infinity of x e to the negative x from 1 to b. Now the reason this is cool, because I can say that this is the same thing as the limit x times e to the negative x is the same as x over e to the x. And I'm going again from 1 to b. So I've got, when I do that, limit as b goes to infinity of what? b, sorry. Yeah, b, no, that's right. B over e to the b minus 1 over e to the 1, or just e. Okay. Now, when I go to try to evaluate this integral, obviously all I'm really concerned about is this left-hand side. This is just going to be negative 1. So I've got limit b goes to infinity of b over e to the b, and then minus 1 over e, because obviously it doesn't matter. Negative 1 over e is not going to be affected by b, because b isn't part of it. Okay, so here, now what can I do? Okay, if I try direct substitution, I get infinity over e to the infinity. That's infinity over infinity. That's no good, so I can use my old friend, and this is what I was so excited about, L'Hopital. Okay, so this limit as b goes to infinity of b over e to the b should be equal to the limit as b goes to infinity of the derivative of b, right, over the derivative of e to the b. So it should be equal to limit b goes to infinity of 1, b, the limit of just b is 1, and the limit the derivative of e to the b is going to just be e to the b. And I've still got my 1 over e over here. Okay, well now I can evaluate this direct substitution. As b goes to infinity, 1 over e to the b becomes 0. So I get 0 minus 1 over e. And so nice. Negative 1 over e. I've got a nice, I mean, at least it's nice I can write it, right? Solution. So this integral has a solution. It converges. It converges to negative 1 over e. All right, so that's using, so just to recap, first we found the antiderivative. So we got our function. Then we use that to evaluate this limit, the limit of this integral from 1 to b of 1 minus x e to the negative x dx. That turned out to be this thing, the limit as b goes to infinity of x over e to the x from 1 to b. We came down here, we did our substitution, b and 1. We split that up because this is not affected by the limit. This is not affected by b going to infinity. That's just negative 1 over e. And then we're left with this thing, the limit as b goes to infinity of b over e to the b. And that's where we can use L'Hopital. So just write that here, from here to here. That's where L'Hopital comes in. All right.